Hello everyone. In this video, we will continue with topic 5.3, electric cells, and in particular, we will discuss some applications of this concept or this model of internal resistance that we have been discussing. So here's a question for you. Why is it that if you're feeling brave, you can lick a 9-volt D-cell battery? I mean, you will notice that you are licking it, but it certainly won't kill you. Please don't try that at home. But if you do the same with a 9-volt car battery, you can actually die. That is, what is it that is different about the 9-volt D-cell compared to a 9-volt car battery that makes the car battery so much dangerous? And the answer is that the total internal resistance of the car battery is much lower. And they do this, they arrange this using a couple of different techniques. One is the 9-volt car battery is made up of sort of liquid chemicals that reduce the effective resistance of those chemicals pretty significantly. But not only that, they also wire multiple cells in that car battery in parallel, okay? It's worth noting they're also wiring cells in series to add up to 9 volts, but for now, just consider the fact that they are wiring different cells in parallel. Now, normally, you would look at this, and on sort of our non-ideal analysis, you would wonder why you would ever do this. But as it turns out, by wiring multiple cells in parallel, you reduce the effective internal resistance of all of them. There's a deep sense in which the different cells in parallel share the load, and it reduces the amount of the current going through the starter that has to go through each of those individual cells. As a result, there's significantly less energy and power loss to the cell itself, and they can tolerate a much, much higher current. Note that in our sort of previous analysis, okay, there is a point of current in a given cell with internal resistance past which that cell cannot provide any higher current. They have a maximum current here given by the horizontal intercept of this graph. So, we'll note that if these are identical cells in parallel, the effective resistance is then reduced by a factor of 3. So consider the difference between sort of the D-cell battery and the car battery here. Note I'm not using actual values here. The actual difference is much larger than is shown. They both obey this equation, delta V is equal to the EMF minus I times R, and the slope on both is minus the internal resistance. But that means the car battery has a much shallower slope. In fact, in this PET example, a factor of 3 shallower slope. As a result, that x-intercept, that horizontal intercept, happens much further down the line. And so the cells themselves can sustain a much higher current, which is effectively how the car battery is going to kill you. That car battery can sustain a much higher current than the 9-volt D-cell battery can for the same internal resistance and external circuit.